Suppose you're given a few numbers, which one's bigger? That it's one of those types of questions, right? Except you're not allowed to do any work on paper, and it might be a tough problem to crack, but simple way to look at it is basically count how many zeros it has. What do I mean by that? Basically, you could just break this giant exponent down to how many numbers you have to multiply it by. So like 2 to the power of 3 equals 8, right? And that's close to 10. And so we just divide 120 by like 3 and we get like 40. Basically, this is equal to like 8 times 40, right? And it's like close enough to 10 to the power of 40 for my lazy ass. So this has like approximately 40 zeros for all I could care about. And 3 to the power of like 2 is equal to 9, which is again close enough to 10 for my sake. So this is like 9 to the power of 45 for all I care. So already we can tell that this number has a lot of zeros. And here we have this here. 4 to the power of 2 equals 16. And if we divide that, we basically get like 16 to the power of 30, since we're dividing it by 2 and whatnot. And oh no, which number is bigger and whatnot. And it basically is, since this number is bigger, it might be blah, 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 blah. For all I could care about, though, this number has the more zeros. This is effectively, for all I could care about, 2 to the 8. And all this is being multiplied by, like, 30, right? So, like, it's basically 230 and 830, and we could go ahead and do that again. So like 810, because we're dividing it by 3, and so we just end up with like 840. Oh hey, would you look at that? These numbers are like basically the exact same amount of zeros essentially. And this number just happens to be bigger both in its base and its exponent, so therefore 3 to the power of 90 is basically equal to well, who cares? It's basically the biggest number here. Yay! Woo, we did it! Yeah, that's basically it. You don't really have to do much complex math in your head. You basically just break it down so that way you basically just have like 10 to the 40. Just how many tens are in this? Like, how many digits does this probably have? This is basically 10 to the 45, and we broke this down really, really easily. 16 is a real weird number to work with, so instead we just broke it down to like 8. So, and it's basically the same thing, 1040. So this one has the most zeros, and that's all we really have to worry about. And in the event that you have to like get into a very, very complex big numbers, I'd imagine all you have to do is just break it down to like its prime components or whatever, and basically try and move it closer to 10 or whatever. I don't know how to put it. It's like not a difficult problem whatsoever. So yeah, have a nice day, everybody. I hope you guys enjoyed this, and you might be able to impress your friends in math class with this trick. Basically, you don't have to do math in your head. You just count the amount of zeros, and you do that by doing the laziest amount of math you can accomplish. In summary, basically, this just simplifies to like, we know that 2 to the power of 8 is 2 to the power of like 3 equals 8. Divide this by 3, and we basically get approximately 10 to the power of like 40 for all I could care. And then we have this 3 to the power of 2 equals 9. Basically, then divide this by 2, we get 10 to the 45. So we already know this is pretty big. And we could do 2 to the power, we do 4 to the power of like 2 equals 16, and this is close enough to like 10 to the power of, again, divide this by like 2, so this is like about 30. If you wanted to like get a more accurate thing, then you could basically do more math in your head. But for all I could care about, this is a good enough number. Not much math needed there. That's essentially the biggest. So, but if you really wanted to be very, very accurate and you're able to do it within your head pretty easily, basically this is about like 20. So it's like 230. So this is like 230 times 10. 30. We simplify this stuff again. This is approximately, for all I could care about, taking from that equals, that simplify that real quickly. Then basically by the power of exponents, you just add these two numbers together, so you get 1040, approximately the amount of zeros available there, which we then find out that these two have approximately the same zeros. Or if we weren't too lazy, or if we already knew from this decent amount of math and we already understood power twos and blah blah blah, we'd probably know that these two are exact same number anyway. So basically that, just make a good estimate basically.